Hi, everyone. My name's Ethan Du Bois, and this is my restoration ecology midterm. I'm going to try and move a little fast here because I'm having a hard time with the time restriction. So what is restoration ecology and why is it important? Restoration ecology is the process of helping a system that has been degraded, damaged, or destroyed recover to a state that it can provide a service. That service could be a few different things, and we'll get into that. A large array of projects fall under this restoration umbrella and include, but are not limited to, the creation of parks, improving wildlife habitat, and the cleanup of abandoned sites. These projects vary in cost, size, disturbance, and time they take. This field is relatively new as it started in the 1980s on the basis of the Clean Water Act and the idea of avoiding environmental impacts. This was so important at the time because people finally realized how much we needed to protect our natural systems and how much we're actually being lost, including 53% of wetlands and 98% of old growth forests. However, like with everything, pushback soon followed. Factors such as cost, time, lack of care, and the fact that you could do a restoration and it could be lost based on nothing in your control, such as storms and other organisms were cited as some of the reasons on why not to restore. There's three types of restorations. The first is complete restoration, which aims to bring back a community to its historical state. One example would be the bog restoration, which was my case study. The second is ecological services restoration, which is a process-based restoration aiming to restore the system, to restore a process, function, or structure. One example that's extremely relevant today is restoring wetlands for carbon storage in the Bavarian Alps project. And the last is experiential restoration, which aims to create pleasure for humans. One example of this would be the Alfred Caldwell Lily Pool project. Novel communities are new communities which are often found in places that need restoration. These are highly disturbed sites like roadside ditches or industrial complexes, which could benefit from one of the types of restorations above, and in particularly experiential, based on their presence in typically in human dominated systems. The elements and challenges involved with restoration. Before restoration begins, you need to consider the following things. Determine what the project's purpose is. Gather the necessary background information, which we're going to get into. Create a vision or a plan. How, what, why are you doing this? Determine what the restoration may look like when it's all done. Does it require management or further monitoring once it's finished? And the 7 main challenges associated with restorations are changing systems, imperfect understanding of natural systems, lack of record keeping, legislative loopholes, unique site history, conflict among users, and the lack of funding. Restoration success is an interesting piece of this larger puzzle as it varies by each project. What is deemed successful for one project might not be considered successful for another. These are all restoration success is strictly based on the goals you set before beginning restoration. So these may come in the form of percent of invasives, percent of a desired species you were looking to presence of a desired species that you were looking to attract, use of a system by a certain group. This could include humans, or changing the system to fit historical hydrologic factors that might have been present back in the day. So there are 9 attributes of a restored ecosystem. And these include contains characteristics of assemblages that occur in the reference ecosystem, which we're going to get into in a little bit, contains native species, all the necessary groups for continued development of the system are present and able to colonize, capable of supporting reproducing population, signs of dysfunction are absent, integrated into a larger ecosystem, potential threats to health and integrity have been removed, resilience against normal periodic stress events, and the site is self-sustaining. So what can we gain from restoration? There are 6 categories: enlarging preserves, linking habitats, restoring remnants, restoring a process, education gain, and for me, maybe the largest piece is increasing community capacity. As we do this and get the community more involved and invested in our project, we might be able to get further help with new projects And this could come in the form of increased funding, increased volunteers, and it could be extremely important for continued restoration in the area and other environmental projects. So some examples that we touched on were a landscape level restoration project, the Malpai Borderlands, a small scale restoration project, the Alfred Caldwell Lily Pool Restoration Project, a project that used volunteers, the Queenlands Restoration Project, and a project that incorporated an experiment, the Bog Restoration Project. Ecological communities are interactions of various species which live together in the same place during the same time period. These communities are based on the following factors: environmental gradients or limiting factors, ability to reach or disperse from another site onto yours, species interactions, and essential relations. Ecological community dynamics can be defined as the variations through time. These changes often are driven by disturbance. Disturbance cycles can deter systems from continuing through their successional stages. So as each disturbance affects each area differently. Although they might be close in proximity, a certain site may have less resilience and in turn go back to its primary successional stage, whereas one with more resilience is able to continue going through its cycle. And this is actually good for biodiversity, as we're going to get into. So as previously mentioned, this is a good thing in most cases. This idea is explained by intermediate disturbance hypothesis, which states that the highest species biodiversity is during intermediate frequencies and intermediate intensities of disturbance. So this plays into a role with resilience, which is the ability to withstand disturbance, is one of the key factors to holding a successional state. So while different systems have different resiliences and disturbance may affect them differently, the differences in those systems allow for organisms to have different habitats in each stage and use all of the different habitats within that landscape in different ways and fulfill their needs from them. Keystone species are a species that play a large role and have significant effects on the systems they live in. One example is the gopher tortoise, which creates burrows that are used by hundreds of species ranging from reptiles to mammals. And these species use these burrows for different things such as foraging, protection, and others. And recently, in the last few decades, we as a society have done a better job with regulation and restriction to protect these species and these habitats that provide for so much other organisms within the ecosystem. So what is an ecosystem? It can be defined as living and dead organisms in a specific area which interact with the Earth's spheres, more specifically, the atmosphere, the lithosphere, and the hydrosphere. Within these ecosystems, energy is retained by the sun, or retained from the sun by the primary producers and enters the food chain. This energy continues up through the various trophic levels and is ultimately released in the form of heat. The biochemical cycle plays a significant role in these systems because that describes the transfer of chemicals such as nutrients and carbon between plants and animals, plants and the ecosystem as a whole, and the atmosphere and the lithosphere and the hydrosphere. And, these play a role in how species are able to interact with their habitats. One example may be the hydrologic cycle on an ecosystem and the changes it causes to plants, which ultimately affects species that use, that consume these plants and the nutrients that are in the system. Landscape ecology describes how many organisms rely on multiple different habitats to survive. Obviously, most individuals are not in one specific, most biological animal organisms are not in one specific habitat for their whole lives. So they require different types of habitat within their landscape that they use. These landscapes are divided into various communities, which are all interconnected and could be considered patches. Each patch varies from the patch next to it in some way, but ideally these patches would be connected. They would have close proximity to resources such as food and water, and they'd be irregularly shaped with efforts made to increase interior habitat and reduce the edge habitat. With all the fragmentation that we have across our country now, one of the serious losses we have faced is a loss of interior habitat, which provides a lot of quality habitat for various species that probably aren't doing as good right now. So efforts should be made to increase that and decrease the edge habitats. Reference systems are needed, although they can be bad in some situations. So they provide a way of evaluation on a restoration project by determining success. They offer a starting point, and they can create excitement and enthusiasm about a certain project from certain stakeholders. However, they can be detrimental as they may act as a pitfall when you're not flexible. They may limit some of the possibilities on the site, and in some cases, they might not be possible. You want to be realistic. You don't want to choose a reference site that requires a lot more than is there and available for you to use. You have to be realistic with what you choose and what you hope to restore a certain piece to. Project documentation is a huge piece of the restoration project and puzzle, as it creates a basis of knowledge that others can use. This prevents others from wasting time and money on methods that you have already deemed unsuccessful, or for trying other methods when they could just try the method that you have already proved works. This has been a huge gap in restoration ecology so far, with a lot of knowledge being lost. And it's something that we should really make more of an effort to push forward, which will ultimately help push the field forward. This documentation can be done by taking notes, taking GPS points, using a work journal to record participants, team report to update progress every so often, photographs, which ties into GPS points and making sure you're taking photographs at the exact same spot, and receipts, which can be an extremely important and easily to forget piece of this, as you want to keep track on the money spent, and the economics plays a large role in some of these restorations. So it's a really important piece. You want to incorporate research to your project. Set up an experiment and release the findings. Of course, you want to release the findings. One example may be determining whether a certain type of pesticide has success removing an invasive species. Obviously, you're not the only person on this planet that is having trouble with that specific invasive species, and you could really save someone else time by producing your results and either telling them this was successful or, hey, don't try this, it doesn't work. Observing contemporary remnants is another way you could incorporate research, and this would be using a mountainside ecosystem. Contemporary remnants are systems that have been left untouched for some reason. They could be right-of-ways or mountainside ecosystems that have not been touched based on their landscape, based on their use, whatnot, and they likely represent a good guide on species composition and native species in the area. And they could tell you a lot on maybe what you need to do for your individual piece. Another way is investigating historical communities, looking at historical aerials or topographic maps to determine what the property once looked like and what it was used for. Could tell you a lot about what, struggles you may face, or what you hope, what might you want to do at that specific site. In Module 3, we read a piece called Early Naturalists, which detailed a variety of topics, including the historical information of soils, landscapes, tree composition, among other things in the Carolina area. And this information can be really helpful when creating a reference site for a restoration project. This should be used to create that, because it allows you to measure and assess your success on a specific project. This could come in the form of a certain percentage of native or historical plant species, or creating the hydrology that was once seen in the area. There's several pieces of data you need to collect during a site inventory, and the three categories are sciographic, including location, slopes, hydrology, soils, climate, and many more. Biological information, which include plants, animals that use and occupy the sites, may have used or occupied the sites, and other factors that may affect them, including what might be limiting on a specific site for them. And socioeconomic information, which includes how humans use the site, what regulations are present, is there access to the site, is infrastructure on the site, such as bathrooms, trails, and whatnot, and the former land uses. So important things to consider for restoration. And we're going to get into the three categories I just mentioned. So sciographic is extremely important, obviously, when planning. And this information allows people to understand what is possible and what to expect. What plants and animals will be supported, when and how can you implement the restoration? And this more specifically is talking about seasons and time of year. And what user activities can you provide that you would hope to, what's plausible and what's possible. Historical data and data in surrounding areas can be found online before you even step foot on the property. So that's a really good idea to do, to get a background knowledge, and then, have a baseline of information before you go on and figure out what's going on actually. And understanding these factors is pivotal before planning in particular, because they provide you information on what's possible and what challenges you should expect. Understanding the biological and socioeconomic information is really just as important. The fauna obviously play a key role in many restorations projects, whether that is you're trying to provide specific habitat, or if species are detrimental that will, hurt your restoration project. As we mentioned before, with their significance in the energy transfer within a food chain, vegetation plays a key role in whatever you're building. So you really want to take that into consideration. And, maybe the most important, socioeconomic factors can really change the course of your whole restoration project. What regulations may affect your project? You might not even be able to do what you want to do. How does surrounding land use play a role? Maybe that stops what you want to do. If you're trying to manage for white-tailed deer on a really small piece, and you have 100 hunters hunting the pieces all around you, it's probably not going to be really beneficial. You're probably helping them out more than you're helping out who actually uses your piece. And does this site provide the amenities you're hoping to? If you want people to be there, you have to provide bathrooms and trails and whatnot. And these factors give you an idea of what needs to be planned and accounted for before beginning the actual restoration. Like we mentioned, historical data is really important. It provides information to help you save time and money. It can tell you what may be possible for your site, and it describes trends and past events that may give you a little bit of an idea on what to expect. We then got into a reading regarding the Forest Service and them making uninformed decisions on fire suppression. And the Forest Service failed to recognize that Indigenous people actually helped restore our landscapes by regularly burning and hunting to manage different populations. I think one of the big things that can be done to avoid these errors are communication with different stakeholders, familiarizing yourself with the literature, not only the literature of your specific piece or area, the literature regarding, restoration that the one you're trying to do and whatnot. And looking at this decision from all angles, you want to see from not only your point of view, but from other stakeholders' point of view, and the point of view of just a normal person who might use this as just a leisurely spot to take his dog for a walk. And transitioning from that, of course, humans are going to impact the site and any piece of land in a variety of ways, or most. And some of the ways they could do this is erosion, litter, soil compaction, and introduction of waste from humans and their pets. And these can be detrimental, but they should be planned for. And that may include allowing certain activities only in certain seasons, limiting the number of users on a site, creating signs to inform people what is and isn't allowed. And I think the last and most important piece is getting community buy-in, which creates a sense of ownership and helps provide people like a reason to not want to do certain things because they want to protect and uphold what you guys have done. Adaptive management is a piece that deals with scientists and practitioners and working together and using outcomes to learn and adapt as management furthers. This technique should be, can use a variety of different pieces, which include small experimental operations, which would be done with the focus of scientists to determine how to proceed. These should be small, time effective, and relatively costless to allow for both sides to get what they want. All actions require monitoring. Of course, you're using adaptive management, so you have to adapt to what you're seeing and what's working and what's not. And this provides ample opportunity to document and share the results moving forward. You have a lot of pieces working together here, and someone should be able to document and let others know what's happening. Volunteers play a huge role in any restoration project. So how do you get them to help? These ways include providing volunteers with new skills, providing them with education, providing them with the social aspect of volunteering, something they could do with their friends, a sense of helping aid in the solution. And some people just want to go outside and work hard. If you're sitting in an office all day, that there is a part of you that probably wants to go outside, at least for me. And I think a big piece of this was providing the volunteers, especially younger people that may be interested in these type of things, skills and education so that they can go and use them in their everyday lives and maybe enter fields like this. But obviously when you get the volunteers there, you want to treat them right. So you want to communicate well, treat everyone with respect, educate them, get feedback on what you're doing well, what you're not. And a cost-effective method is provide food, make it an enjoyable experience, buy a couple pizzas, and let everyone have fun and get lunch, and hopefully keep coming back. Regulations play a huge role, as I previously mentioned, in the socioeconomic piece. And some of the big ones for these type of projects include the Clean Water Act, Endangered Species Act, and the River and Harbors Appropriation Act. So these create a need for mitigation. As a developer, there's 3 steps to developing a piece of land. You want to avoid impacts to wetlands, streams, and other aquatic resources. If you can't follow number 1, you want to minimize the unavoidable impacts. And number 3, you want to offset the unavoidable impacts by mitigating. So mitigation can be completed in a few ways. You could preserve an existing site. This is a really rare occurrence that we're not going to touch on after this. You could establish a new aquatic site, which I would say is the most one of the popular methods. Enhance an existing aquatic site's functions or restore a previously existing wetland or aquatic site. Mitigation banks provide this service to developers who are in need of fulfilling their credits. So mitigation banks are sites where the system has been restored, enhanced, or preserved by individuals, typically a consulting group, where developers can buy that site in form of credits to make up for the impacts they have created. So when determining the amount of mitigation needed, several factors come into play, including loss type, what type of system was lost or disturbed. Priority type, was a rare or primary priority system impacted? Existing condition, what did the system look like before it was disturbed? Duration, how long will it be adversely disturbed? Dominant impact, what type of impact was it? How does it affect it? Did you fill something, or did you just degrade it for a little bit of time? Cumulative impact, how much development is in the area? So as a developer, you really only have 2 options. You can buy the required amount of credits from a mitigation bank, or you can find an area that needs restoration, and you or an employee of you hire someone to restore that piece and see how many credits you can get. So to see how many credits you can get, you consider the following factors. Net improvement, is an upland buffer included? Credit schedule, when is the restoration taking place? In a perfect world, it would be before the disturbance, but it's almost likely never. Temporal loss, time between loss and replacement. Is the replacement system the same as the system? Is the habitat types exactly the same? And how close are you to the replacement system? So lastly, we looked at a mitigation project that occurred on the Clemson campus and dealt with the Honeycutt Creek and its associated wetlands. This was used as a mitigation project for a newly developed shopping center in 2012. However, I believe at the point of the data, which was 2017, I believe this is an unsuccessful mitigation project based on the following criteria. There was no long-term removal of herbaceous vegetation and shrubs. Obviously, this is going to take a little longer than 5 years, but it seems like no real progress has been made. While invasives have been kept in check, pest species have not. Not to mention that there's probably likely more than 1% of invasives on the site. There's been no changes to hydrology. It's still likely too wet for a bottomland hardwood. There's been no erosion control from the wetland. There are no duck boxes have been installed and no boardwalk has been created. Based on these factors, I believe as of 2017, this mitigation project was unsuccessful, although it has had some positives. It hasn't touched on nearly what it hoped for, but it'd be interesting to see what it looks like in 2021 or 2025. Thank you.